Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on mechanics from Specimen Paper 1 for exams from 2022. In today's class, we are talking about Specimen Paper for 2022 and the total time for this paper is 1 hour and 15 minutes. If we go to the second page of this paper, we can find values of some very important constant. For example, value of G at AS level, you have to use 9.81 meters per second, and the speed of light in air and vacuum is also given. Charge on electron is given to you. 1 U means 1 atomic mass unit is given to you. Mass of proton is given. Mass of electron is given. Avogadro's constant is given. Molar gas constant is given. Boltzmann constant is given. Gravitational constant is given. Permittivity of free space is also given to you. Planck's constant is given, and Stephen Boltzmann constant is also given. So these constants are very important and their values as well. So maybe you will need them for some calculations in this paper. So if you need them, you can simply come back to second page and you can find the values of constants. On third page of this paper, you can also find some important formulae. The first one is about uniformly accelerated motion. Means when acceleration of the body is uniform. Or simply we can say when acceleration of the body is constant. Or even you can say that when acceleration of the body has just one value and acceleration is not changing with time, then we can use S is equal to ut plus 1/2 at square. We can also use v square is equal to u square plus 2as. S is the displacement, is not the distance. Displacement is equal to distance when the body is moving in a straight line. So you have to be very clear. S is displacement, not distance. Distance and displacement, they are equal in magnitude if the body is moving in a straight line. And the second one is for hydrostatic pressure, means delta P is equal to rho G delta H. Rho is the density of the fluid. Upthrust F is equal to rho G V. Rho is the density of the fluid and V is the volume of the fluid displaced. V is not volume of object in the liquid. V is volume of fluid displaced. Volume of fluid displaced can be equal to volume of the object inside water if the object is fully submerged inside the liquid, means it is fully inside the liquid. Then volume of fluid displaced and volume of object, they are equal. So you have to be very clear about this one. Let's go to next one. Doppler effect for sound waves. So this is formula for Doppler effect for sound waves. F naught here, this is the observed frequency. Fs is the frequency of the source. V is the speed of sound in that medium, and Vs is speed of source. Next one is for electric current. I is equal to A N V Q. This is also called transport equation. I is current, is cross-sectional area, N is the number density, mean number of free electrons per unit volume, or number of charge carriers per unit volume. V is drift velocity, and Q is the charge on single electron. Now you can say on single charge carrier. Next one is about resistors in series. Very basic formula. This is also given to you. The last one is about resistors in parallel. So this is for resistors in parallel. For question number 1, it is given to us a student creates a table to show reasonable estimates of some physical quantities. Which row is not a reasonable estimate? So if you look at the first one, option A, if you look at this one, this is about heater. And the power rating of a heater is 1600. Power rating is 1600 watts by 120 volts. Means the power is this one if the potential difference across heater is 120. And from here we can find out value of I. So this will be 1600, means the power divided by V. And this is approximately equal to 13.3 amps. And this value is close to this one. So this is a reasonable estimate. Simply this one is a reasonable estimate. Now if we go to option B, mass of a person 70 kilogram, average mass, this is also reasonable estimate. If we go to option C, maximum speed of an Olympic sprint runner 10 meters per second, this is also a typical value, means a runner, it can cover 100 meters in 10 seconds. seconds, in 10 seconds. So the speed is about 10 meters per second. So this is also a reasonable estimate. Now from here simply we can see that D is the right answer. So this is not possible. So let's try to understand why this is not possible. P in this case is given to us. P is equal to 10 to 6 Pascal, but P is equal to rho GH, and in this case we are talking about water. P is given, so this is 10 to 6. So density of water, this is 1000 kilograms per cubic meter. G, for simplicity we can use this is 10. So here is H, so we can find out value of H means the depth, the value of depth we can find out from here. So H from here will be equal to 10 to the power of 6 divided by 10 to the power of 4. So this is equal to 10 to 2 meters, means 100 meters, very deep. This is talking about garden pond, so it cannot be 100 meters. It can be few meters but not 100 meters. So this is not a reasonable estimate. So answer for this question is D. For the second question, we need to find out which expression has the same SI base units as pressure. So first of all, let's try to write down SI base units for pressure. Pressure is equal to force over contact area. Unit of force is Newton, but force is equal to MA. So we can write down SI base units for force. SI unit for mass is kilogram, and SI unit for acceleration is meter per second per second. And SI unit for area is meter square. So simply we can replace F and A with their SI units. So here we can write down kg, meter per second, and this is divided by meter squared. Now if we simplify this one, we can simply write down kg over meter. This meter, if we bring here, we can write down this is meter, and here we can write down this is second square. Now kilogram, this is unit of mass, so the quantity is mass, so we can write down mass here. Meter is unit of length, mean this is unit SI unit of length, so we can write down here. And second is SI unit of time, so we can write down time squared here. Now simply we need to compare this one with given options. If you look at option C, this one is correct option. For this question, it is given to us the speed V of a liquid leaving a tube depends on the change in pressure delta P and the density rho of the liquid. The speed is given by the equation, means by this equation. It is also given to us K is a constant and K has no units. We need to find out what is value of N, means what is value of this exponent. We need to find out. So now we need to understand if an equation is correct, it has to be homogeneous, and homogeneous equation must have same units on left side and also on right side. So let's try to understand this one with one very simple example. V is equal to U plus AT. If you look at V, means the unit of speed, final velocity, meters per second, and the unit of initial velocity is also meters per second, and unit of acceleration is meters per second, and unit of time is second. If we simplify this one, we can simply write down meters per second, and if we simplify this is also meters per second. Now you can see each term has the same unit, and units on left side and right side of this equation are the same. So this equation is correct and this is homogeneous. And so this equation is homogeneous. So this is the main concept we need to understand. Now let's try to apply this concept here. So simply we can write down unit for V first of all. So otherwise I can write down this equation again. As K has no unit, so let me rewrite just K here. So this one is delta P by rho to the power of N. Now we need to write down the units. Unit of speed is meter per second. K has no unit, and the unit of P we need to understand. P we have already discussed. This is force over area, so we can say its unit is kg, meter per second square, divided by meter square. So we can simplify this. This will be kg per meter per second square. So I mean this is SI base unit for P. So this is one thing we need to understand. SI base unit for P. We can also write down SI base unit for density, that is kg per cubic meter. Now simply we need to plug in these units. So for delta P, we can write down this is kg per meter per second square divided by kg per cubic meter. The power of this one is n. Now from here we can cancel this kg with this kg, so we can cancel out. I will be writing here, so let's move on to this side. Meters per second. From here we can simplify. You see the power of this one is -1. So if I rewrite this one, so we can write down, if I take this one to the numerator, so this will be plus, and this one is -1, and this is s to the power of -2, and here we have power n. So we can further simplify this one, so we will write down here, this is meter square, and this one is s to the power of -2, and the whole power is n. So we will take this one to here, so this is meter square, this is per second square, so the power is n. Now these two units have to be the same. So how we can make these two units same? If n is equal to 1 by 2. So simply if n is equal to 1 by 2, so then units on both sides are the same, and this equation is correct. So n has to be 1 by 2. So the answer for this one is A. This is very common question and typical type of question. Concept is the same. Just follow step and you will be able to find the answer. For question number 4, we need to describe which row correctly describes the quantities, momentum, power, and temperature. So if you look at option A, momentum is scalar. Momentum is not scalar. Momentum is a vector. So this one is not correct. Power is scalar. This is true. Temperature is vector. This is not correct. Momentum is scalar. It is not correct. Power is vector. Not correct. Temperature is vector. Is also not correct. If you look at option C, it is given to us momentum is vector. It is true. Power is scalar. This is true. Temperature is scalar. This is also true. So the answer is C. If you look at option D, momentum is vector. It is true. Power is vector. No. Power is scalar. Temperature is scalar. This is true. So the answer is C for this question. So simply you need to understand momentum is vector, power is scalar because power is equal to work done over time. So it's a scalar. Temperature is also scalar quantity. When we talk about temperature or we talk about power, we need to talk about direction. So that's the reason power and temperature, they are scalar, but momentum is a vector quantity. For question number 5, it is given to us a ball is thrown vertically upwards. It takes a time of 3.20 seconds to return. It is also given to us, we can assume that air resistance is negligible for this question. We need to calculate initial speed of the ball. So first of all, let's try to sketch. Imagine that this is the ball. We throw this ball upwards with velocity u. So this is the initial speed of the ball. So this ball will go up, it will reach maximum height, and then it will fall down. Means it will come back. So it will come back at the same position. Means the initial and final positions are the same. As initial and final positions are the same, it means that displacement of the ball is equal to 0. Displacement is 0 because initial and final positions are the same. For this question, we need to calculate u, means the initial speed we need to calculate. But total time of flight is given to us, that is equal to 3.20 seconds. Acceleration due to gravity is equal to 9.81 meters per second per second. Now we need to assume one direction as positive. So in this case, we will assume upward is positive. So we are taking upward direction as positive because we need to find initial speed, and initial speed is upwards. If we take upward positive, it means our answer will be positive. But also we need to understand acceleration due to gravity is always downward. So acceleration due to gravity is downward because force of gravity is acting downwards. Acceleration and resultant force, they are always in same direction. So that's the reason acceleration is downwards. As we have taken up is positive, so acceleration has to be negative because it is in opposite direction. Now we need to understand acceleration is also constant and it is uniform. So simply we can use s is equal to ut plus 1/2 at square. Displacement in this case is equal to 0 because initial and final positions are the same. So displacement of the ball is equal to 0. We need to find out initial speed, but the total time of flight is given, that is 3.20 seconds. So we can write down plus 1/2. A in this case is negative 9.81 and time is 3.20 second square. Now if we solve this one for u, our final answer will be 15.7 meters per second, and this is positive. It means initial speed is upward, mean initial velocity direction is upwards. So our answer for this question is C. For question number 6, it is given to us a radio controlled toy car travels along a straight line for a time of 15 seconds. The variation with time t of the velocity of the car is shown here. So you can see on y-axis we have velocity and on x-axis we have time. Question is asking us, we need to calculate average velocity of the car for the journey shown by the graph. So the first thing we need to understand is, what is average velocity? V average is simply equal to the total displacement of the car divided by time taken. Total displacement divided by time taken. Now if you look at VT graph, we also need to understand area under VT graph is equal to displacement. So simply we can say area under VT graph, this is equal to displacement. Area under VT graph is equal to displacement. So simply I will write down DISP. So area under VT graph is equal to displacement, and displacement is a vector quantity. So we can say displacement is a vector quantity. If we look at this area from T0 to T10, this area is positive. So it means displacement is positive. And this area is equal to 30 meters, means 3 times 10. So this is positive. If you look at this area, this is negative. And in this case, we have 6 times 5. So this is equal to negative 30 meters. So the net displacement in this case is 30 minus 30 meters divided by time taken. And the total time taken is 15 seconds. So our final answer is 0 meters per second. In this case, average velocity is equal to 0 because the net displacement is equal to 0. So the answer for this question is B. For question number 7, it is given to us the acceleration of free fall on Pluto is 0.66 meters per second per second. It is also given to us the weight of the object on Earth is 6.0 newtons. We need to find out what is weight of the object on Pluto. So the first thing we need to understand, the value of G on Pluto is very small as compared with value of G on our planet. So it means the weight of the object on Pluto will be very small as compared with weight of the object on Earth. So this is the first clue, first thing we need to understand. So it means that answer cannot be C, answer cannot be D. So simply you can ignore these two options. So the answer is A, our answer is B. And the second point we need to understand, the mass of the object remains same. It doesn't matter wherever the object is in this universe. Mass does not change. So first of all, we need to find out the mass. So we will talk about Earth, means when the object is on Earth. So we can find out the mass. Mass will be equal to weight of the object divided by the value of G. In this case, we have weight that is equal to 6.0 newtons, and we need to divide by value of G, that is equal to 9.81. So you have to use 9.81, not 10. So if we divide by 9.81, our answer will be 0.612 kg. So this is the mass of the object. Now we have the mass of the object, so we can find out weight of object on Pluto because we have value of G on Pluto. So I will simply write down here W for Pluto. So this is simply equal to M times G on Pluto. So this is G on Pluto. Mass we have, this is 6.12 kgs. We have to multiply with acceleration, so that is 0.66. If we solve this one, our final answer will be 0.404 newtons. So the answer for this question is A. For question number 8, it is given to us a stationary firework explodes into 3 pieces moving in the same plane. The masses and velocities of the 3 pieces just after the explosion are shown in this figure. So as you can see here, we have one piece mass is equal to 100 grams, and the other 2 pieces the mass is equal to 50 grams and 50 grams, and the velocities are given and angle is also given. Question is asking us, we need to calculate what is value of v1 and v2. For this question we need to understand, in the question it is given to us that just after the explosion. So it simply means that in this case no external force is acting on the system. As there is no any external force acting on the system, system, so we can use law of conservation of momentum. And this momentum is in two directions, so we have to consider momentum in two dimensions. We need to consider momentum in two dimensions to calculate v1 and v2. First of all, we will consider momentum along horizontal, and we will take to the right as positive. So simply we will say initial momentum of the system has to be equal to final momentum of the system along horizontal, means along x direction. In this case, initial momentum means along x direction is equal to 0 because this firework, it was at rest, it was stationary. So P initial is equal to 0. Now, if we look at momentum of this is along horizontal, mean along x direction, so this is positive. So we can simply write down 50 gram, we will be using G here, times V2 cosine of angle 60 degrees. Now if you look at momentum of the piece 1, so the momentum of this one means the velocity is to the left, so we will take this one as negative because we have taken to the right positive. So the momentum of piece 1 is 50 gram v1 cosine of 60 degrees. From here simply we can say that 50 gram v1 cosine of 60 degrees, this is equal to 50 gram V2 cosine of 60 degrees. We are just using mass in grams because it will be cancelled. So in this case now you can see 50 gram we can simply cancel with 50 gram. Cosine 60 we can cancel with cosine 60. From here we can find out V1 is equal to V2. So this is one point we need to understand. V1 is equal to V2. Now let's consider momentum along vertical, means along y-axis. As there is no external force acting on this system, it simply means that momentum along vertical is also conserved. And we will take momentum upwards as positive. So that's the reason I have drawn this arrow. It means upward momentum is positive. So we will start from here again. Initial momentum of the system along vertical has to be equal to final momentum of the system along vertical. Initial momentum of the system along vertical is equal to 0. So we have to consider final momentum. Final momentum also has to be 0. So we have three pieces. So piece 1, it has momentum along vertical. So we can write down its momentum is equal to mass of piece 1. We will be using mass in grams because mass will be cancelled. We no need to convert into kilograms. But if you want to convert into kilograms, you can also convert. Result will be the same. So I'm using mass in grams. So I have written 50 grams mass of this is. And the velocity component along vertical is V1 sine of 60 degrees plus momentum of second piece along vertical. Mass of second piece is also 50 grams and the velocity component along vertical is V2 sine of 60 degrees. Now if you look at momentum of 100 grams, its momentum is downward, so we will take this one as negative. So we can write down the mass of this multiplied with its velocity. Velocity is negative, downward is negative. Now we need to simplify. As V1 is equal to V2, so we can replace V2 with V1. So we can write down 50 V1 sine of 60 degrees plus 50. I will replace V2 with V1. So we can say 50 V1 sine of 60 degrees minus we have 800. Now you can see this is 50 V1 sine of 60, 50 V1 sine of 60. We can take this 800 on other side. So I will write down 800 here. So this will be positive. So we can multiply this one with 2. So we can say 2 times 50 V1 sine of 60 degrees. Simply we can say this is equal to 100 V1 sine of 60 degrees. But we need to understand sine of 60 degrees is equal to root of 3 by 2. So we can write down here this is 100 times V1 root of 3 by 2. And this 2 we can cancel with this one. So we got 50 here. Now we will simplify this one for V1. If we simplify this one for V1, our final answer in this case will be 800. So this is 800. This is divided by root of 3 times 50 times 50. And if we solve this one, our final answer will be 9.2. So this is value of V1. But V1 is equal to V2. So it means it is equal to 9.2 meters per second, because V1 is equal to V2. So V2 is also equal to 9.2 meters per second. So the final answer is B for this question.